We're doing lesson 13 of our unit 2. There's 17 lessons total this unit, so we're almost there. We're learning like our last chunk of skills. And this unit is called linear equations, which we've looked at how to create them, how to solve them. But it's linear equations and systems of linear equations. So now we're getting into all the different ways that we can solve them. You'll see that there's pros and cons to each way. And that's why we teach you all the ways so that you can be a good problem solver. Yesterday, we started an activity that is still a good activity, although maybe the end felt rushed. So let me just recap that for you. We looked at two different constraints. So one of the constraints was that Diego has a budget of $15 to spend. We made an equation to represent it. You could see all the different combinations that you could have that make this equation work. All right, we looked at that yesterday. Then we added a different constraint where he's buying a total of 2 pounds and saw all the different combinations you could have for that. If we put the equations together to create a system of equations, so that would be 2 equations that have the same variables. If we put them together, there is only one pair that works for both constraints, and that's this one, which you can see there. And then if I go back to the previous page, it is down here too. All right, so this would be the solution to my system. It's only pair that works for both. So that's what a system is 2 or more equations, and they have the same variables. Where they intersect is where the solution is. So that's why yesterday we had you typing it into Desmos. Know that Desmos is great to check your answers. It should definitely never be a starting point. You still need to know how to graph by hand, and that's what we're going to focus on today, is how to do that by hand. Because on your constructed response, you will have to graph a system by hand and identify the solution. All right, so the solution is where they intersect. And here's all the different possibilities you could have where it intersects once, where it never intersects, so there's no solution, and where you graph 2 lines, but they're right on top of each other. So they're constantly intersecting, and that's where you have infinitely many solutions. All right, we're gonna focus today on just the graphing and graphing by hand. Again, you could use Desmos to check your answers, but that should never be like your starting point. You can always tell when you actually know how to graph and when you're just trying to copy Desmos, because it's really don't. All right, but first some vocabulary. So we have a system of linear equations. All right, a system of linear equations, also called a linear system, consists of 2 or more linear equations that have the same variables. How do linear equations look when we graph them? How do I know if something's linear when I'm looking at the graph? Not necessarily parallel, or end up, yes, a straight line. So linear, it's kind of in the name, line, straight lines is what we're looking at. Linear equations, exponential equations, and quadratic equations are all the different kinds we're going to look at this year. Linear is probably the one you're already familiar with, and if you're not, you need to. Like, you need to buy in, you need to start learning so that the rest of your high school math experience goes by pretty easily. So when you think linear, you should be thinking straight lines. What's the formula for our straight lines? Y equals mx plus b. That form is the one that we usually graph from. The one that we usually make equations from is usually in this form, not always. there's different ways to write your linear equations, but they could all be rearranged into y equals mx plus b, which you should know how to graph. So it means there's no limit at all unless you're doing like 2 plus negative 1. Okay. So system of linear equations. 2 or more linear equations with the same variables. A solution to a system of linear equations is any 2 variables in an ordered pair form that satisfies all of the equations in the system. So where before it just had to make equation work, now it needs to make both equations work. A sentence phrase is phrased a little weird, but just know the solution to a system is the ordered pair that makes both equations true. We just talked about it a few seconds ago, so let's see how much you remember. Table 6, how many solutions does graph A have? 1. 1 solution. So here's our 1 solution example. The solution is where they intersect. So although these are not labeled, like I don't know exactly what ordered pair it intersects at. The ordered pair is always written x first and then y in parentheses. So whatever x value it intersects at, that would be the value for x that makes both true. And wherever value for y that it's at makes the rest of the equation true. Now notice this says that 2 lines are plotted on each of the graphs below. So table 7, if I graph 2 lines, but they're right on top of each other, like in graph B, how many solutions do I have? Infinitely many solutions. So that's where if you graph and it happens to create the same line, the equations might look different at first. Maybe you rearrange them and they become the same. Or a few lessons ago, we talked about equivalent equations. That would be them having the same slope and the same y-intercept. So even without graphing, if I see they have the same slope and same y-intercept, I know it'll be infinitely many solutions because it's the same line. All right, table 8. What about for graph C? When they never intersect, what's my solution? No solution. What types of lines are shown here? Parallel lines. So, I mean, you can assume they're parallel. They look pretty parallel, but you'll see in geometry, you can't assume things. So oftentimes you'll have to look at the equation to make sure that they have the same what? Good. Same slope, different y-intercept. And I'm using M and B because of y equals mx plus b. No, I'm in slope, B is y-intercept. All right. But yeah, if they look like that, there probably are no solution. Sometimes they do try to trick you and one of them is angled slightly. So they will intersect eventually, but if you look at the equations and it's no solution, they have the same slope, different y-intercept. Questions on that? The rest of the vocab on that paper, like the blanks, you don't really need, so we're going to skip that. We're going to go right into the examples. Maybe in algebra 4, they'll ask if it's consistent, inconsistent, and things like that, but it's not going to ask you that on your on your test, so don't worry about that. So I'm gonna do 2 with your assistant, and then you're gonna try 2. So when it comes to the part about you trying to, know that like when I go over the answers, I'm just projecting them. So you can't just sit there and wait for me to do it for you, because you won't have enough time to like copy the whole thing when it's presented. You need to be able to fix the mistakes. All right, but here's 2 to start with. When we are graphing by hand, how would I go about that? We learned 2 different ways. What's one way that I could do it? You have to be able to graph a line. Something you should have learned before. What do you usually graph first? X to Y. Okay. If you're wanting to graph by X and Y intercepts, maybe that's what you're talking about. You could, sometimes the X and Y intercepts, maybe they're not visible on your coordinate plane. Maybe they're decimals. But you could, like we did that on the Pear Deck day, where if they went on 0 rides, how many rides did they go on? Or what did we plug in? You could do that for this first one. And that's what my last hour said too. So if I'm solving for my x-intercept, how do I do that? I think you're thinking of something different, Cadence. The class said they wanted to solve by X and Y intercepts. So if I'm solving for my x-intercept, by definition, your x-intercept is when what happens? Talking to all of you, and this is going to take forever. It's already taking forever. What's true at the x-axis? Here, let's take a look, see. This coordinate is 0, 0. What's this coordinate? What's this coordinate? What's the one right next to it? So what's true at the x-axis? The y is 0. Okay, great. This is something we've learned before, so I'm losing a little faith. But if I want to solve for my x and y intercepts, starting with the x-intercept, I need to make the y 0. And then I solve for x. What's 2x plus 0? Yep. What's opposite of multiplying 2? And whatever you do on one side, I get x equals 3. And this is my x-intercept. This is not my solution to the system or anything. If we're solving by x and y intercepts, I just found out what x was, and that was when y is 0. And then I can plot that on my coordinate plane. On the x-axis, because it's your x-intercept. Then you could go back and solve for your y-intercept. So if I want to find my y-intercept of that equation, what has to be 0? Dx. So that's what I'll do. It becomes 2 times 0 plus y equals 6. What's 2 times 0? What's 0 plus y? And that's my y-intercept. If you're writing it in coordinate form, it's 0, 6, but it should be a 6 on the y-axis, and that can work a lot of the time. But the trick is you want to make as straight of a line as possible, because you need to be able to see where they intersect. So if it's just like a janky line, you might not get the right. That's why I kind of prefer the other way of graphing that you might know better. So I'm surprised we said this first in both of my classes. Which is putting it into what? Y equals mx plus b. And that's what I'm going to do with the second equation. I'll show you that way. What's isolated in the y equals mx plus b? The y is isolated. That's what I mean. Like we want to get the y alone, and then that would make it slope-intercept form. So then how would I get the y alone? Okay, I have to add the x and the y. Okay, I can't combine the x and the y. I do need to add the x here so that it cancels out to 0. And then whatever I do on one side of the equal sign. So then that's what gets this to go away, right? So that way it could be 0 plus y. That would just be y. This I could leave as 3 plus x because they're not like terms. It does not become 3x. But to make it look more like mx plus b, I like putting the x term first, which you are allowed to do so long as you're not changing the signs. Like these are both still positive in the way that I wrote it. Okay. Now I'm going to graph this. Hopefully you know how to graph. If you don't, maybe write these steps off to the side. This one won't take a whole example. But when you are graphing, first you are wanting to make sure that it is in y equals mx plus b form. If not, isolate the y. Then what do you usually plot first? Nope. The b, which is your y-intercept. So plot your y-intercept. But you can only see two things really clearly in your slope-intercept form, and that's your slope and your y-intercept. Y-intercept is usually your starting place. So that's b, and y is mx plus b. What's my y-intercept in this one? So I'm gonna put a dot on the y-axis where the 3 is. Then you need to be able to use your slope. So use slope, which is m, by the way, and y is mx plus b. It's the one that's always in front of the x. So what is in front of the x if it's not written? 1. So my slope for this one is 1. Technically 1 over 1. You always want to think of slope as a fraction. So if it's not written as a fraction, make it 1. Because you still have a run, always. Not written as 1. So that's where you would use slope to plot the next point. And I say points because you need enough to see where they will intersect. So use as many as you need to create a perfectly straight line. So from my y-intercept, I'm going up 1 to the right 1. My rise was 1, my run was 1. Do enough to where you can make a straight line or see where they intersect. If you are doing this by hand and don't have a ruler, you could just use like the edge of one of your papers. Not on your test. Already is lagging my face. Okay, so that's how you graph. The skill of graphing is not necessarily what I'm supposed to teach you. You should hopefully already know that. You just reviewed it, so maybe just know it moving forward. The skill is identifying your solution to the system as what? So we graphed them. Great. What's my answer? One, 4. It's the coordinate that they intersect at. So write your answer in coordinate form. 1, 4, it always goes x first and then the y. If you were to write it on a test without parentheses, you would lose a point. So you know how to write your coordinate. But that's my solution. Questions, comments, concerns? Okay, that one took a long time. So if you had to dust off the cobwebs, like show you one more and then I'll have you try the next 2 on your own. So this one, try to be a little better. So first thing you need to check when you're solving systems by graphing. Is this first one in slope-intercept form? Yes, it's in the format y equals mx plus b where the y is alone. So yes, I have everything I need to be able to graph that. Table 2. What is my y-intercept for that one? -2. So on my graph, I'm going to put a dot where the -2 is. It's there. The signs do matter. So if it's -2, it's below the origin on the y-axis still. And then table 3, what is my slope for that one? We're just looking at this first. 2. 2 over 1, technically, if we're doing rise over run. But yeah, the second equation, we still have to do stuff to. We can't like graph that one yet. But first one's in slope-intercept form, so I can start graphing from my y-intercept. Because my slope is 2, I'm going up 2 to the right 1. You still have a run. It's not written as 1. So up 2 to the right 1. I have no idea where they will intersect, so I just need to put enough points that I can make a straight line. Question so far. Then now we need to put the other one into slope-intercept form because it's not. Table 4, can you tell me how I put something in slope-intercept form? How will I know that it's in slope-intercept form? Like, how do you know that this one's in slope-intercept form and this one's not? Okay, so if I can get the second one to equal y and nothing else, then I can start graphing it. Okay, so table 5, what do I need to do to that second equation to start isolating the y? Can everyone else start anticipating like the next question I'm going to ask? It's the same process. You want the y to be alone. How do I get the y alone? We learned this a few lessons ago. Table 5. What do I need to get rid of first to get the y alone? Okay, 6x. So I always tell you get rid of what's farther, and this, in order to get rid of it, needs to become +0. I don't want to get rid of just the x. I want to get rid of the whole term, right? I want to make it +0 so that it can cancel out. Class, how do I cancel out a +6x? And whatever you go inside. So then that cancels this. I have 3y. Are these like terms on the right side? No. You could leave it as 18 minus 6x as long as you know which is your slope, which would be y-intercept later. I like writing it like this so it looks like mx. It's still positive, 6x is still negative. Table 6. How do I get the y fully isolated? What's currently happening to the y? Okay, so right now it's multiplying by 3, and then opposite of that would be to divide by 3. When you guys don't answer, I give you a different question. Opposite of multiplying by 3 is dividing by 3. We're going to do that on both sides. Remember our warm-up from a long time ago? You have to do it to both terms and simplify. So now the y is alone, because 3 over 3 is 1. 1 times y is y. Class, what's -6x divided by 3? -2. And what's 18 divided by 3? Now this is something in slope-intercept form that I can graph. Now let's graph it. Table 7 with what plot first? And my y-intercept is good. Now table 8, how do I know where to plot my next point? Use the slope, and what is my slope in this one? -2. If it's not written as a fraction, make it a fraction by writing it over 1, so that you remember that your run is 1, right? It goes rise over rise. Since my rise is negative, I'm going down 2 to the right 1. Down 2 to the right 1. Until you see where they intersect, or until you have enough to make a straight line. And now where they intersect is your solution for the system. So table 9, can you tell me what the solution to the system is? 2, 2, written as a coordinate like this. Good, question? If you are struggling through this, highly recommend the IXL thing I told you about. I already have some students submitting their extra credit for it. IXL seems to be a safe space for all of you. It does teach you how to do the questions. So, I don't know. This is the new skill should be identifying the solution, not the step-by-step graphing and rearranging. Questions on that? Okay. So now try the next 2. I'm going to leave these up as an example. So if you get stuck with these, I'm going to give you 5 minutes. Fully graph them yourself. At least give it your best attempt before I project the answers. We do need to see other types of examples, so I'm just going to project these ones. And this is in Schoology, doesn't mean that you just copy it from there. Try them and then see if you're right. It was like kind of like how I provided the key for the homework. And just copy it. Because cheating on your homework doesn't get you much, but knowing how to do it is what you need for the test. So let me full screen. These 2 are the ones I asked you to do. Your coordinate plane is a little bit different, but if you did it right, your solution should be at the -2, 2. So our coordinates are slightly different, but if you did it right, it intersects at -2, 2. For the second one, your coordinate solution where they intersect is -2, 4. Again, our coordinates look a little bit different because I made yours to be going up by 1, whereas mine is going up by 2. So I changed that for you. But what you should have noticed is that the first one and this one is already in slope-intercept form. You can just start graphing it. When I do grade your test, because it'll be something just like this, solve it by graphing. I do check that you have the correct y-intercept and that you have the correct slope. So like I do count for this one, I go down 2 to the right 1, down 2 to the right 1. I see if it lines up. Often I'll see kids just like have the right y-intercept and just like draw a line. And it won't even line up to the solution. Okay, you can't use Desmos to replace this skill. But you can use Desmos to check your graph and your solution. So that's the first one being graphed. The second one, you did have to rearrange into slope-intercept form, or you could do like the X and Y-intercept method that we did at the very beginning. Up to you, but you need to be able to graph it by hand. And to do that for this one, first I need to subtract X on each side. Then I needed to divide 2 on each side. What's the number in front of the X if it's not written? a 1. And in this situation, it was a -1. Your slope is allowed to be a fraction. In fact, it's easier if it's a fraction versus going down 0.5 into the right one. You'd want to go down 1 to the right 2. So that's my fraction. My y-intercept simplifies to 1. So that's what I graph first. And then I use my slope to find the rest. Questions on that? Now moving on to this one. One of them is already in slope-intercept form, so you just go ahead and graph that one. Plot your y-intercept first, use your slope to find the next points. And then this one you had to rearrange. But this one was a little easier to rearrange because it was just one step. To cancel out the -x, you add x on each side. And now you can graph this. So 6 being your y-intercept, 1 being your slope, so going up 1 to the right 1, until you find where they intersect. Now this one, you might have had to work backwards in order to see where they intersect, because they don't intersect to the right. If you have to work backwards, you do the opposite of going forwards. So if my slope is up 1 to the right 1, to go backwards, I'd go down 1 to the left 1. Down 1 to the left. Good there? If you're a slow note taker, then it is in Schoology. We do need to see the other types of solutions. So this is all just one solution. And you do need to tell me what that solution is if it is one solution. What coordinate does it intersect at? We're going to look at when it's a no solution or infinitely many, how that looks graphed. Okay, so now this one. The steps don't really change. It's just what you notice when you graph it. So table 9 is the first equation on this one in slope-intercept form. Okay, what would I plot first? -2, you always plot your y-intercept first. Then you use what to find your next points, class? The slope. The only other number you can see in your slope-intercept form. Class, for this one, my slope is 2. And it's helpful to make it a fraction if it's not already. My slope is 2/1. So from my y-intercept, I am going up 2 to the right 1 because it's rise over run. Up 2 to the right 1, up 2 to the right 1. If for some reason I needed to work backwards, I'd go down 2 to the left 1 from my y-intercept. You know you're on the right track if you made a straight line. If it's not straight, then something's wrong. I'll put my line there in a second. But that's the first one, already in slope-intercept form. Table 1 is the second one in slope-intercept form. No, because how do I know if it's in slope-intercept form? When it's y equals mx plus b, meaning the y is isolated on one side. So the first one was great. That's why we could already graph it. The second one, I need to isolate the y. Table 2, what do I need to do? What math to isolate the y? Add 2x, and whatever you go on one side, back. So then I have y equals, you could leave it as 4 plus 2x. I'm going to write it as 2x plus 4. That's the same thing. I just like this better, but up to you. As long as you know that your single number is your y-intercept. My y-intercept is 4. That would be here on my graph. And that the number in front of the x is your slope. So class, what's my slope for this one? Good, 2, and then if you want to make it a fraction, slope should be a fraction. Now notice I can't go to the right at all on this one, so I must have to work backwards. I need to do the opposite of what the slope is telling me. So instead of going up 2 to the right one, I'm going to go down 2 to the left one, down 2 to the left one, until I have a straight line or see where they intersect. But what am I noticing at this stage? They will not intersect because what type of lines are these? Parallel. And usually you shouldn't assume. So I have to look back at my equations. They both have the same what? Same slope.
Different y-intercept.
Different y-intercept. If you notice that before even graphing, then you already know what type of solution?
0.
No solution. Right? Okay. One more that you'll see, and then you'll try 2 more, and then we'll be done. Questions so far? Getting into here. Table 3, are any of those equations in slope-intercept form for part B? The first one is. So great, we can graph the first one pretty easy. Class, what would I have to graph first? The y-intercept, and my y-intercept is, so I'm going to plot that first. And here is -3 over y-intercept. Y to the sky. When that goes up and down. Table 3, what's my slope for that one? 3. So if you want it to make more sense to you, always make it a fraction by putting it over 1. So that your rise over run, you're remembering that you still have a run. So from your y-intercept, go up 1, 2, 3 to the right 1. Up 1, 2, 3 to the right 1, and that's all the spacing. Now table 5, is that second equation in slope-intercept form? It's not, because the y is not alone. If I can get it alone, then I can graph it. Table 6, how do I get the y alone? And this one, how do I get rid of this -3x? Good, I'm going to redo one side of the equal sign. To the other side. This gets the y alone. And this is now in slope-intercept form. Granted, I'm going to write the x term first. But that's my preference, but if I'm doing that, make sure you're keeping the 3x positive and keeping the -3 negative. And what are we noticing at this step? They have the same slope. Does that mean it's a no solution? They have the same slope and also the same. So when I go to try to graph it, I should notice that I'm right on top of the same line. And therefore, how many solutions do I have? Infinitely many. Good. All right. Now you have a couple to try on your note sheet. Try them. I will project those answers in about 5 minutes. Should you finish those 2, then yeah, work on your practice. It's evens or odds if you didn't do that on your practice. For your practice, I won't be able to check it tomorrow, so whenever you do finish it, just upload it. That's how you get a grade. All right, but do the you try. I'll leave these up as an example. If you are finished early, we're going to practice. Okay, so
The U-tries were these two, and you can see the work shown. I'll also explain it. So one of them was already in slope-intercept form. That makes it easy. That makes this a good method. We will still show you other methods to get the answer, but when one of them's in slope-intercept form and you have the means to graph it, then this is a good method to solve it. So when I graph it, stop talking, please. I have my y-intercept at -2, and my slope is -1/1. So from my y-intercept, I'm going down 1 to the right 1, down 1 to the right 1. If I need more, then I'll go backwards. I'll do the complete opposite. Up 1 to the left 1. It should make a straight line. If it's not, then you did something wrong. Then the next one is not in slope-intercept form. I think this threw a lot of you off, but how do I know if it's in slope-intercept form? If the y is alone. So whatever you need to do to get it alone, that's what you need to do. And whatever you do on one side, you do to the other side. Not to each term necessarily, just once on each side of the equal sign. So like subtracting x is what I chose to do first. It doesn't really matter. They're both equally as far from the y. 0 minus x is -x. Opposite of adding 2 is subtracting 2. And these are not like terms. You can't combine them. So when I rewrite it, it looks like this, which is in slope-intercept form, which is something I already graphed earlier. They're the exact same. And so my answer is infinite solutions, infinitely many. Good? Okay. So now in number 4, one of them was already in slope-intercept form. Y-intercept's -1, slope is 2/3. So going up 2 to the right 3, making a straight line as I can. And then the other one I had to rearrange. So get the y alone. To cancel it out, I would add 2/3 x to each side. These are not like terms. So this is all I can do is just rewrite it. And then plot it. What you should have noticed is that these lines are not touching. When I look back at my equations, they have the same slope, different y-intercepts. Yeah, these are 1s, but one of them is negative. So they're different locations. So no solution. Good. Any questions? All right. And again, yeah, Desmos is a great tool. You can use it to check your answers. But if on the test, I'm not seeing that you know how to properly graph your y-intercept, how to properly do your rise over run, you will lose some points. So don't just use Desmos to start, use it to check. Questions, comments, concerns? Okay. Well, that is all. You have the rest of the time to work on your practice. Don't pack up till 10:29.